let's go through LeetCode 127, word ladder. For this question, it gives us a begin word and an end word. Also give us a word list as a dictionary. For every operation, we can change one of the letter to, for example, this I can change from A to Z. As long as the change word is in the word list, we can do such an operation. So let's count how many steps we can we are going to transfer from the begin word to the end word. For example, the heat. In the word list, it has a hot, dot, dog, lot, log, cock, and it find the shortest distance is 5. And for example, it goes from heat to hot, and go to dot, dog, cock, and this is one of the shortest paths, and return the shortest path the length. So for this question, we have the word list, right? So one of the things that we can convert this one as a set, trying to see whether the set contains the inner word. So we'll have set string equals mirror hash set word list. So if this set doesn't contains, right? Doesn't contains any word, we'll say we'll return 0. And we know we can do from the beginning word. We have the end word, right? Every time we can change one letter. So we can try to see if for this kind of word, what is a possible neighbor or child, right? So that is after changing one of the word in it. After changing one of the word in it, how can this kind of word to be, right? And also this word need to be in this kind of dictionary. So this will be its child, and also from this child we can go to another child, right? And until we meet the end word, then this is step 1, step 2, and we have BFS, right? Until if we meet in some kind of layer, then we have a steps here. Then we return the steps. So it will be kind of straightforward. One of the things that we need to make sure is that from one word, we have the word dictionary. From one word 1, how many words it can, how many child it will have, right? So one of the way we do that is that we iterate every word in the dictionary, right? Trying to see, for example, word 2, word 3, and trying to compare this word 1 and word 2, whether they have just one character differences. In that case, if this kind of there are n number, right? And every operation of this will be if the word the length is L multiplied by n, right? But we can do something efficient is that we can change every character in word 1, right? For example, it is hog, and we're trying to see whether from H change it from A to Z, right? Trying to see whether AOG is in the dictionary. In this case, it will be 26 multiple by L for each operation, right? So this will be more efficient that we check the set whether contains the one we change one character. Another thing is that for each word we find its neighbor, we can create a map, right? Map string and set as for each word its neighbor, right? We can construct the graph at the beginning. But the thing is that for this graph, the thing is that we compare every word with the word in the dictionary, right? So if we construct the graph at the beginning, it will not be very efficient. Actually, we know this is BFS, right? So for every layer, if some kind of word has been visited, we can remove from this dictionary. So in every layer, we just from one, we have a function, have a string as input, and also this is set, right? Set as a dictionary as a second parameter, and return a list of string that will be its child. Because for every layer, if some kind of word already being visited, we can remove from this set. This will be more efficient than we construct the graph at the beginning, because this set for every layer, it will be shrinking. So that is another improvement for this kind of question, right? Of course, for this question, we already know the beginning word and the end word. And there is some other way to do that, like bidirectional BFS. But to do bidirectional BFS, it will be the code is very like a template, and also easy to make an arrow. So I say I don't like that kind of solution. For that one, we need to have two sets, and also the forward weight or backward weight, and have a temp set trying to swap. But that kind of solution is like a template, and you need to just remember a lot of things. Not so. For me, I prefer just to do the traditional BFS. So let's begin to write a word for this. So we'll say this is BFS, right? So we need to have a Q equals new array, yeah, right. And we'll have Q offer this begin word, and we are going to have a set string as weighted, right? Continue hash set. So we'll say while this string is not empty, right? This Q is not empty. Because we want to have the stacks. So So we know for this one, it returns returns a file because hot dog dog cock. This is a file, right? So that means if the begin word equals the end word, it will return 1, right? It will have this one also belong to one node. So we'll have steps in the steps initially to be 1, right? So we need to do bilayer input size equals q dot size, and for I equals 0, I smaller than size, I just plus we'll say how string current equals q dot per. And for each layer, we have steps plus, right? And let's say if current equals and word, we just return steps, right? So we'll have this for each string. Next, we'll have write a function called get next. Okay, and we are going to pass in current string and also the date, right? And I'll say if visited, let's put visited add begin word, right? If visited next contains visited contains next, we need to continue. Otherwise, we are the visited add next, and also we'll have queue offer next, right? We are going to, as we mentioned, we need to write this kind of function, right? What we have to approach is that get next. We compose a map at the beginning, right? In that case, it have we just to consult the map, but we have some improvement here. Is that for every word, right? We visited, we can remove from this kind of dictionary, so that in the during the BFS we can like from our branches, like we don't need to have the whole word set. We can shrink the word set because the one we already visited, we don't need to put to consult that with the word list anymore. So we can do the first improvement here is that we can have a list of string. For each layer, we have a list, right? plus new array list. And if okay, and we need to for each string we'll have list add current. And after this for loop, we say for each string tr in list we'll have a dictionary. Remove this tr, right? In this case, this dictionary will be shrinking. So this will be one of the improvements. So let's begin to write this function called get next. We'll have a list of string, return as a list of string, get next, and the string word, and we'll have set string dictionary. Right? So this will be our function. Our second improvement is that instead of trying to iterate every word in the dictionary, the thing is that we just change one character, each character in the word, translate whether the dict contains the word. So let's write this one. List in string result equals new array list. So let's change this one to be char plus word to char. So we'll say for int I equals 0, I smaller than array dot length, right? Right, plus plus, and we'll have char c equals array I, right? And we are going to do is that for char for example, ch equals a, ch smaller equal to z, right? Ch plus plus, and we'll have array I equals ch. If it contains new string array, right? Let's do this. String here equals, if this one contains this, we'll have result and here, right? And the thing is that if this ch equals c, that word does not change, right? So we need to continue. And also after this for loop, we should change back array I equals c, right? And then in the end return result. Yeah. So this will be our help function to get next. And for this one, BFS, right? So if does not find the end word, we'll return 0. Validity. We didn't have a, we should put this one here, right? After this. So this one, let's try to submit.